this video, we're going to do a deep dive into the world of server objects. Game Plumbing Framework is server authoritative. The way we accomplish that is by putting all of our game state in things we call server objects. Examples of server objects are like the player's account could be one server object, or if you have a leaderboard, that would be another server object. If you have a game with a map, the map would be a server object. If you have a matchmaker game, the matchmaker would be a server object and the match would be a different server object. Now, these are all systems that you've seen and you can get from other parties, but then you're held hostage to their assumptions about what your requirements should be for that. So with Game Plumbing Framework, you can build your own matchmaker any way you want, or your own map any way you want, or even something we haven't listed. Because at the end of the day, a server object is just a C# object. However, you don't have to roll your own stack. You can develop it in Unity, and it's already doing some very powerful things for you, like persisting, and it's taking care of networking and synchronization. So you don't have to worry about any of that stuff. It does it securely, it does it at scale. So we're going to do a demonstration of how to mess around with a server object from Unity. So the first thing I want you to notice is if you go Game Plumbing Framework Settings, you'll get this screen. And we just want to make sure our backend type is simulated and not cloud. Because in simulated, we can test our server objects without having to deploy them, which is a major speed up. And here we have test runner up. This is how we're going to develop server objects. So if we open this code, we have this coin test, and coin test interacts with a couple of server objects. One is called coin player SO, and coin player SO interacts with coin leaderboard SO. So I'm going to go into coin player SO, and I'm just going to edit some of the code here. And I'm going to even add a breakpoint. Now I'm coming back into Unity. And I'm going to run my unit test. Because I'm in simulated mode, a few really cool things just happened. One is I hit my breakpoint. So I have my full stack debugging even though I'm building server code. And the other super cool thing is I was able to run this without having to do a deploy. So basically, I instantly changed code and I tested it, and it felt a lot like I was writing client code, but this is code that's going to end up on the server. So let's take a closer look at what's going on. If we look at coin test, we have this constant players equals 2. For each one of these players, we're going to create we're going to run this player actions task. So if we look at the player actions task, we're passing in a number, 0, then 1, and we're creating this username. We name the syncer based on that username. We get a player ID from registry.getID, which I call our ID store, and we get a reference to this particular player, and right here we're referring to it as me, and we set its username, and then we have it flip a coin, either 1 or 2 times, and we do that by sending it the flip command, and then we sit here and we wait to make sure that it's been flipped. And then when all is said and done, we wait to make sure that the leaderboard is initialized, and we're just asserting that there are entries into the leaderboard. So let's one thing we can do, since we've run this, is we can look at what it looks like with the diagram trace tool. I'm going to choose SimCloud. Here I see both players, coin player 1, coin player 2, and what we're observing is first the client sends a message to coin player 1 saying, hey, set my username. And in doing so, the coin player 1 will send a score up to leaderboard. It'll receive scores back. The client will send a flip to coin player 1. We can ignore this stuff. This is for coin player 2 basically doing the same thing. But as a result of this flip, coin player 1 does this flip result message to itself, and then it sends its score to the leaderboard. It receives some scores back, top scores, and that is essentially the flow. So we can look at some code to try to reconcile that. But one thing I want you to notice is we don't really talk about the messages from coin player or coin leaderboard back to the client that sync its state up. And that's because this isn't so much a network perspective. That is happening as the object on the server side is changed. It is under the hood. It's updating the client and all of the variables that the client is concerned with as far as the state of coin player. But it's not going to show you that in the diagram, because the idea is that you don't worry about that level of interactions. You're just concerned with these messages that we've coded up and architected. So let's see what that looks like in the code. So we saw that we were sending this set username. So if we go into coin player, we have a handler for set username, and it says, hey, I can handle stuff from the client. That's a security measure. And set username is just defined right up here. And it is a message that has an attribute called username. And it uses that. And then it goes and it sends a message over to the leaderboard. And here we're just saying the leaderboard has this ID of 0. And so it's going to send this score. And we saw that as soon as the username was set, we sent that up. Then the test comes in and tells the coin player SO to flip. So we're handling that right here. We have a flip handler. So you'll notice that our handlers are all called handler, but what makes them different is the type for the message. And you'll also notice that these are all strongly typed messages. They don't have to have any fields in them, but they could. So here we have an example of a field, but here we have an example of a message without a field. And the way we handle this is, okay, the client told us to flip, so we're going to do a random, and we're going to decide whether we're heads or not. And then it does something interesting. It sends a message back to itself called flip result, and it's going to wait some amount of time, flip seconds. And the flip seconds is to simulate, okay, this thing is taking some time, but the reason it sends a message back to itself is because we need to be able to reconstruct a server object just simply based on the messages that have been sent to it. So by sending itself a flip result message, coin player SO is becoming deterministic, even though random was a non-deterministic call. So let's see how we are handling the flip result message. We come down to the handler with the message type flip result. We see that we've defined flip result right above the handler, and we're basically saying, okay, if this is heads, our current streak is incremented because the whole game is about how many consecutive heads can you get. Whereas if it's tails, our streak goes to 0. if our streak is longer than our longest, let's go and update the leaderboard. Here we have the, hard-coded leaderboard ID is 0, and we're going to send it our longest streak along with our username. So let's see how the leaderboard responds to that. So now we're in Coin Leaderboard SO, and it is handling the send score message that we were just talking about. It does that by changing it has this dictionary, which is essentially the leaderboard, and it updates it with the information, the username and the score that it just received. And then just because this is the way the game's designed, it'll send back all of the top scores. So the Coin Player SO can have its own version of the leaderboard. And there's a big difference between the Coin Player SO and the Coin Leaderboard SO, in that Coin Player SO, if we look at the class definition, it's syncable, which means the client can come in and basically read all of the values. So it can read this leaderboard and bind it to its UI, whereas Coin Leaderboard SO is not syncable. So the client has no visibility on what's going on with Coin Leaderboard SO. So that's why we are in this implementation sending the top scores back. Whereas if Coin Leaderboard SO was syncable, then then you could automatically display those values. So that's about it. Today we've gone through an example of some server objects. We've seen how server objects let us have a server authoritative game without having to roll our own back end, without having to worry about persistence or networking or how to sync this stuff to UI. But it still gives us the flexibility as if we did that, because we have these very comfortable C# objects where we're defining the game logic, and we're even able to develop it from within Unity. So thank you so much for your time and looking into server objects, and I look forward to you using these server objects to build server authoritative games. Thank you.